We're going to find the volume of the solid of revolution that's obtained by rotating the region bounded by the parabola x squared plus x plus 1, the line y equals to 4x minus 1 about the y-axis. Now in the video right before this, we used the washer method, which was quite involved, and it was a long problem and fairly difficult to show that the volume came out to be pi over 2 units cubed. In this video, we're going to use the shell method, and you'll see that for this problem, the shell method is much easier than the washer method. Now, sometimes the shell method is easier than the washer. Sometimes it's the other way around. But sometimes you can't even do one, and you can only solve a problem by using the other. So you should know both methods. First, set x squared plus x plus 1 equal to 4x minus 1. This will give us the x coordinates of the point of intersection. So that would be x squared minus 3x plus 2 equals 0. X minus 1 times x minus 2 equals 0. X equals 1 or 2. We have 2 points of intersection. Plugging these in, we find that when x is 1, y is 3, and when x is 2, y is 7. Those are the 2 points of intersection. Now, we need to know which is on the graph is the parabola above the line or vice versa. To find that, you pick a point, the value of x between 1 and 2. So say we pick 3/2. Let's plug it into the line first. We get 4 times 3/2 minus 1. That's 5, which is 20 over 4. And then we plug this same 3/2 into the parabola. We get 9 over 4 plus 3 over 2 plus 1. That's 19 over 4. So 20 over 4 is larger than 19 over 4. It means the line lies above the parabola on this part of the on this interval. So let's go ahead and graph it now. Here's what the region looks like. This point here is the first point of intersection 1, 3. That point there is the second point of intersection. That's point 2, 7. The line is above the parabola, so we connect them with a line segment, and then part of the parabola connects them here. This is our region. In the previous video, we kept track of horizontal slices of the area which generated a washer. This time I'm going to pick any x between 1 and 2, and right above it I'm going to look at the vertical slice of the area. It looks like this. As it rotates 360 degrees, this vertical slice generates a cylindrical shell. As it goes all the way around, cylindrical shell has it's like a cylinder without the top and the bottom. So the secret to this is to find the area of the cylindrical shell, not the volume, the area of cylindrical shell, multiplied by dx gives it a little bit of thickness of volume, and integrate from 1 to 2. So let's recall when we have a cylinder like this, and cylindrical shell is just this lateral surface area. That's the area around the cylinder without the top and the bottom. It has radius r and height h. If we cut the cylinder along the height, say here, and then unfold it, it becomes a rectangle. The height is now the width. The height of the cylinder is now the width of the rectangle. What used to be the base, the circular base here, turns now into the length. That's the circumference of a circle with radius r, which is 2 pi r. And so then the area of this rectangle is now the area of the cylindrical shell. It is 2 pi r h. And so we want to express the area of the cylindrical shell that you see in the graph as a function of x. Therefore, our volume will be 2 pi times the integral. We're taking x's between 1 and 2. If you look at this picture, here's the center of the cylinder, so the radius will go all the way to here. That's x. It's our cylinder. And the height is right there. It's a difference between the y coordinate on the line minus that on the parabola. The y-coordinate on the line is 4x minus 1, and on the parabola x squared plus x minus 1. And so once we integrate this, we'll have the volume of our solid of revolution using the method of cylindrical shells. So this is 2 pi times the integral 1 to 2 x times 4x minus x is 3x minus x squared minus 2 dx. If we multiply through, we get 2 pi integral from 1 to 2 3x squared minus x cubed minus 2x dx. Well, this is an easy integral to evaluate. We have 2 pi. The integral of 3x squared is x cubed minus 1 over 4x to the fourth minus x squared evaluated from 1 to 2. So let's plug in 2 first. We get 8 minus 4 minus 4, that's 0, minus, we plug in 1 now, we get 1 minus 1/4 minus 1. You can see these ones cancel, and we end up with 2 pi times 1/4, which is also pi over 2. So the answer is the same if you use the shell method or the washer method. Of course, it has to be the same because the volume doesn't change depending on which method you use. So now you can compare the two methods and make sure you know how to do this problem using both methods in case you'll need them later.